-10, the real numbers. You're going to learn to determine if a number is rational or irrational, plus a few other things. This is a difficult lesson, guys. You're going to want to take some good notes on this one. Okay, you need to recall that rational numbers can be written as fractions. A lot of times when you think of a ratio, you think of a fraction. Rational numbers can also be written as decimals that either terminate or repeat. So this is written as a fraction, so it's rational. This decimal terminates, it ends, okay? And it can be written as a fraction. So this decimal right here is also considered a rational number. This line right here tells us that this decimal is a repeating decimal. Repeating decimals can be written as fractions, so they are rational numbers. The square root of a perfect square is a rational number. Now this one might not jump out at you, but you maybe see 144 in there, and the square root of that is 12, so there's a relationship between those there. So the square roots of perfect squares are considered rational numbers. Irrational numbers can only be written as decimals that do not terminate or repeat. Remember, terminate means ends. If a whole number is not a perfect square, then its square root is an irrational number. And as an example, if you put the square root of 2 in your calculator, it's going to give you, about that much of it. Put it in a better calculator, it'll give you more, but it never terminates, meaning ends, or repeats. So the square root of 2 is considered an irrational number. So are all the other square roots that are not perfect squares. All right, here's a little Venn diagram to help you keep some of this stuff straight. The set of real numbers is made up of all of the rational numbers that we just talked about and all of the irrational numbers. Add up the rational numbers plus the irrational numbers, and you get the real numbers. Okay, so we're supposed to write all the names that apply to each number. So the square root of 5 is that's not a perfect square. And so that's going to be irrational. If you were to put it in your calculator, it'd be a big, long decimal. And it is considered a real number. Negative 12.75 is a decimal that terminates. It comes to an end. So that is considered a rational number. If a number is rational, it is also real. The square root of 16 over 2 needs to be simplified before you can decide what it is. Square root of 16 is 4, and 4 over 2 equals 2. So that's just a regular old whole number, which is a whole number. It is also an integer. Those are all the numbers that appear in my number line. It is rational, and it is real. Okay, again, we're supposed to write all of the names that apply here. Square root of 9 is a perfect square, so that's 3. So that's going to be a whole number. It's an integer, a number that appears on my number line. It's rational, and it's real. Negative 35.9 is a decimal that ends, so it is a terminating decimal. That makes it a rational number, and all the rational numbers are also real numbers. Square root of 81 needs to be evaluated. That's 9. 9 over 3 is 3. So that gives us a whole number, integer, rational, and real. Now sometimes you get a set of directions that is a little bit different. Here they're giving you 3 choices. You can choose rational, irrational, or not a real number. So you're just going to pick one thing, and that's it. The square root of 15 is a whole number that is not a perfect square, so it is considered to be irrational. 0 over 3 is just 0 divided by 3. It simplifies to 0, and 0 is a rational number. You have the same 3 choices here. The square root of negative 9 is not a real number, and the reason is a negative under the radical. There is nothing like it. You can't do 3 times 3 to equal negative 9. That doesn't work. You can't do negative 3 times negative 3 to equal negative 9 because that equals positive 9. So that doesn't work. There's nothing you can multiply times itself that will equal a negative number. So any negative number under the radical is going to be not a real number. Now, 4/9 you might notice is actually a perfect square because 2/3 times 2/3 equals 4/9. So that is a rational number. If you put in 4/9 in your calculator and hit square root, it will give you 2/3, which is a rational number. Same story here, rational, irrational, or not a real number. We've got the square root of 23, which is a whole number that's not a perfect square. So it's going to be irrational. If you put it in your calculator, you get a big long decimal that does not repeat. Anything over 0 is not a number, not a real number. For example, this fraction could represent, I have $9, which I'm going to distribute equally, or divide, that's what the fraction line is, among my 0 children. How much does each child get? Well, you can't answer that. There's not any logical answer to that, okay? So anything where there is a 0 in the denominator, that's going to be considered not a real number. Okay, once again, we've got a negative number under the radical. Negative under the radical equals not a real number. Our fraction for D is actually a perfect square. It's 8/9, which is a fraction, so it is considered to be rational. Okay, so here's a crazy property you'll never talk about again, probably. It says the density property of real numbers states that between any two real numbers is another real number. This property is also true for rational numbers, but not for whole numbers or integers. For instance, there is no integer between -2 and -3. So here's a question that has to do with that density property. All they want to know is, can you find a real number that's between 3 2/5 and 3 3/5? And a lot of you can probably just do that in your head, but if you really don't know what to do with that, you can basically just add the two numbers up, they did here, and then divide by 2, and it basically gives you the average of the two numbers, which gives you a number right in between them. So if you work that all out, it comes out to 3.5. So you can always just add them together and divide by 2 if you're asked to find a number that falls between two other numbers. So here's one more like that. Find a real number between 4 3/7 and 4 4/7. So you can just, there are lots of different answers that would be correct, but you can just add the two numbers up and divide by 2, and then that gives you an answer of 4.5. Here's a little quiz for you. Go ahead and pause, work the problems, and then turn it back on. Let's just talk about number 4 for a second. I don't think we really did an example like that. Square root of 4 times the square root of 9 equals the square root of 36, which then equals 6. And so that is a rational number. Although I guess you could have just done that's 2 times 3 equals 6. Same idea.